everybody, and welcome to our science lesson for today. I really love teaching science. I like doing lots of experiments with you, and I hope we'll be back in school soon to do those. Today though, I've planned a few different activities for you which I hope you will enjoy. So the first thing we're going to do is I'm going to show you some objects like this one. For each object, I would like you to think of what material it is made of. In year 2 you did lots on materials. What is a material? A material is something that an object is made from. So what do you think this is made from? The pestle and mortar, which is used for grinding spices. Have a think about that one. The next one is a candle holder. Makes this noise. Candle goes in there. I've got a bit of melted wax on there. This one makes this noise. This might help you to decide. Felt tip. A bottle. Could that one be made of? A little model animal called a springbok. They're beautiful animals, some of my favourites. A tea box. Ooh. And a medal. We're looking at this bit of the medal. Have a look, pause the video. What are they all made from? They're made from 3 different materials. That's my clue. Did you get the same answers as me? I'm going to show you them now. So I've got my table with metal. So some of them are made of metal. Some of them are made of plastic. And some of them are made of wood. I'm going to show you the objects one at a time. Shout out what they're made from. This one is made from wood. Good job. Candle holder. Metal. Tea box. Tin. Yep. Which is a metal. Springbok model. Wood. Plastic. And the final one, the bottle. Plastic, but reusable. So that's good. So they're all made of metal, plastic, or wood. Your mission, your first mission, which should only take you about 5 minutes, as it's our mini starter, I would like you to get a piece of paper or a whiteboard, draw 2 lines down, 1 line across, and write metal, plastic, wood. You're going to use this to be a detective around your own house. I would like you to find objects made of these materials. So if I had just done that hunt in metal, I would write tea box. What could I write in plastic? Felt tip pen, good job. Felt tip pen, felt tip. Wood, I'm going to write my springbok model. See how many you can find for each column. Come back in 5 minutes and we can share. Off you go. How many objects did you find for each material? I also went off whilst you were doing that, and I noticed my table was made of wood. I also noticed some of my photo frames. In my hallway, I've got a whole wall of photos, and all the frames around the edge are made of wood. Plastic, I looked in my fridge, and I've got lots of yogurt pots, as I really, really like yogurt. And metal, I found my earrings. Most earrings are made of metal, normally silver or gold. What did you find? If you'd like to share, upload them to your portfolio, and I'd love to see them. On with the next part of our lesson. So today our focus is going to be magnets, as our topic is forces and magnets. And magnets create a force. Just like in guided reading, in science we have our star words. These are words that come up and they help us understand the lesson. So the first one we have is push and pull. And I've got them together because they're opposites. Back before Christmas, we experimented with pushing and pulling objects. Show me an action for push. That's right, like you're pushing a swing. Can you imagine you're pushing someone on a swing? So you push away from you to make something move. What does a pull look like? Remember, it's the opposite. Imagine you're pulling a rope like in a tug of war. So you pull something towards you. Both push and pull make things move. For example, I've got a pen here. When I pull the lid, it comes off, so I'm moving it towards me. When I push it away from me, it closes. So pushes and pulls are essential in everyday life. My next one is magnet. Where can you find magnets around your house? Like this one. Did you find a magnet on your fridge or on your radiator? That's where I have mine. I use them to put things on my fridge, like photos, like special letters or reminders of things to do. Some of you before Christmas during our home learning told me it looks like they stick to things, and I understand what you mean. For example, if I have my earring, when I do this, it looks like The earring sticks to the magnet. But does it stick in the same way as sellotape or glue? Some of you are probably laughing right now at this thought. It doesn't stick in the same way, but I understand why you think that. We're going to explore why it looks like objects stick, or some objects stick to magnets today. We've then got magnetic. My turn, your turn. Magnetic. Clap it out. Magnetic. What does that mean? Magnetic is when something is able to, as you would say, stick to a magnet. So the earring is magnetic. Let's do an action. Magnetic. So they're pulling towards each other. This earring gets pulled towards the magnet. If magnetic is when things are pulled towards the magnet, what does non-magnetic mean? Non-magnetic are things that do not get pulled towards the magnet. They do not stick, like the carpet. Or, for example, like my springbok. Nothing happens when I touch it with the magnet. This one is magnetic, magnetic. This one is non-magnetic. Can you do that? Non, do a cross, magnetic. Because non means not. Let's clap it. Non-magnetic. Fantastic. Attract. Attract is when, this is the proper word rather than stick, is when something is pulled towards the magnet. So we say the earring is attracted to the magnet, or the magnet attracts the owl. So the magnet pulls the owl, it attracts the owl. For example, it does not attract the springbok. It does not pull it up. So we're going to do attract. They pull together. My turn, your turn. Attract. Fantastic. The next one is repel. So if they do not attract, they repel. They push each other away. They don't like each other. My turn, your turn. Repel. Attract. Repel. Fantastic. The last one we have is pole. You might have heard pole for North Pole and South Pole. Magnets also have something called poles, which we'll learn about later in the lesson. Okay, I'm going to tell you a word. I'd like you to do the action. What was that action for magnetic? Good job. What was that action for attract? Did you get it? What was that action for repel? Opposite. Push away, repel, attract. Repel, attract. What was that action for non-magnetic? Non-magnetic. Push, pull, attract, repel. Are you getting them right? Non-magnetic. Magnetic. Oh, and for poles, we say it's the end of things. Like the North Pole and South Pole, the opposite ends of the world. The opposite ends of the magnet are called poles. So we can have poles. My turn, your turn. Poles. Well done. So today's lesson is going to be all about magnets. I would like you to write down what you know about magnets already. Don't worry if you're not sure or you don't know very much yet. That's okay. So on a different piece of paper or your whiteboard, you're going to write magnets. You're going to draw a bubble around it, and then you're going to do a brainstorm. A brainstorm is just writing all the ideas from your head around the word magnets. Sometimes I have so many ideas, it feels like a storm in my brain. So we're just going to write down what we know. So I've written, you find it on a fridge. So I haven't written a full sentence, I've just written find on fridge. The second idea I've written is they can be different shapes. These ones are round, but they aren't all round. What shape are yours at home? And the next thing I've written is magnets hold train carriages. I've drawn a little picture here. So trains are very, very heavy, so they need very strong magnets. A magnet like this could not hold a train. A train is made up of carriages, which are different parts of it. People can sit in this one, and they can sit in this one. The carriages are attached by very strong magnets. Imagine how strong they have to be to stay stuck together or to stay attracted when the train is moving. So I know they're used for that. You might write other uses of magnets. And I've also drawn another shape of a magnet I have seen. This is called a horseshoe magnet because it's like a horseshoe. Okay, I would like to spend a couple of minutes on that before we go on to our next bit. You ready? So today I am learning to understand the different poles of a magnet. Do you remember our action for poles? So we're learning about the different ends of the magnet. We have lots of magnets in school which I'm going to get for next week's lesson so we can have a closer look at them to help us understand. Before we do that, we're going to talk about magnetic and non-magnetic materials, as that's really important today. So I'm going to write magnetic on one whiteboard. What does that mean? That's right, objects that are attracted to magnets, so the magnet pulls them. And then we have non-magnetic, things that are not attracted to a magnet, So we already had earlier that this was magnetic, but this was not magnetic. It doesn't pull it up. So that would go in here. I'm going to show you some objects. I know some of you did this before Christmas, but we're going to revise it again. If you haven't done it, you can join in now. Arden submitted a lovely photo of her where she collected things from around her house and made a pile of magnetic and a pile of non-magnetic. After this, if you'd like to, maybe you could have a go. Okay, let's have a look at the objects. So I've got a hair clip, I've got staples, I've got a little wooden hand that I use for arts and crafts, a glass marble, a 1p coin, a 5p coin, a wooden tree decoration, a plastic lid from a lip balm, a hairband to tie my hair, a battery. I'm going to move these down so you can, got so many objects to show you. Some chalk, a rubber, a hair clip, a pin, a button, oh I haven't put my pin in, here, and a French coin. This is 10 centimes. As I hold them up, I would like you to call out magnetic or non-magnetic. So magnetic, things that stick to magnets, that the magnets attract. Non-magnetic, things that will not stick or will not be attracted. Predict, before we do it, predict which ones you think will go in here and which ones you think will go in here. Ready? The lip balm lid. Okay, let's try it. It's non-magnetic. The rubber, let's try it. If you've got these at home, you might do this at the same time. The wooden little hand, like the springbok, made of wood, non-magnetic. The plastic button, non-magnetic, it doesn't attract, it doesn't pull it towards the magnet. What about this one? Does the magnet pull it? No, it doesn't do anything. What about the 1p coin? Ah, you can see it pulls it towards it and you don't even have to touch it, look. Oh, was doing it just now. There we go. I didn't touch it. I get this close. I can do it from about this distance and it's attracted. The hair clip. Yep, also attracted. The hairband. Nope, doesn't work. The hair clip. Doesn't work. Oh, but it works this side. Can you see I don't have to touch it because the magnetic force is so powerful it can just pull it without touching it. So this part is made of metal and it's attracted to the magnet. This part is not. Wonder what it's made of. What do you think it's made of? I'm going to put it halfway. This is magnetic, this is not. Staples. Did you think it was magnetic? Chalk. Non-magnetic. Marble. Glass. Non-magnetic. Pin. Oh, that bit is. But the bottom bit isn't. Look, if I try and do it with the green part, oops, it doesn't work. Why? What's the green part made of? The green part is made of plastic, so I'm going to put it just like the hair clip. Part of it's magnetic, part of it's non-magnetic. The pin, magnetic. Ooh, the 10 centimes coin is non-magnetic. That's strange because the 1p is. Let's test the 5p. Non-magnetic. And the last one, the battery. This is non-magnetic. Can you think of a part of the battery that might be magnetic though? Have a look. This bit is. Look how it holds it. The top of it is, and the bottom of it is. Why do you think this is? We'll find out in a minute. And the outside isn't. This is because it's made of a plastic coating, and this protects us when we use batteries, because when we use batteries, electricity runs through it. So let's put this in non-magnetic. What do you notice about the non-magnetic? Is there a pattern in the materials? What do you notice about magnetic? So I can see all of these are made of some kind of metal. So this bit's made of metal, this bit's made of metal, and all of this. Most of this is not. We've got wood, plastic, wood again, fabric, so cotton, glass. But there are two items that puzzle me here. Two. Which ones are confusing? These ones. Why? I'm confused as all of these metal things are magnetic because the magnet attracts them, it pulls them. But these two aren't. But they're still made of metal. Some of you might think that all metals are magnetic, but as we can see, this is not true. There are actually only, let me move these, 3 types of metal that are magnetic. That means all of the objects we just saw which are magnetic must be iron, we don't say iron, we say iron, nickel, or cobalt. Some people say it's cobalt. Depends on how you pronounce it. So everything that gets pulled towards a magnet or attracted must be one of these 3 metals. No other metals. So not all metals are magnetic. Interesting fact, huh? We're now going to move on to talking about the poles of a magnet. So magnets are made of metal. And you get them in different shapes. In school we have ones which are these shapes. You can see they're rectangular. These are called bar magnets because they look like a chocolate bar, a bar magnet. And in school, I'm going to show you these next week when I go and get them. They have a line down them. One half is blue and one half is red. Why do you think this is? Is it just for decoration? No. This is because they have 2 poles, here and here, here and here. One of them is called the North Pole, so I'm going to put an N, and one of them is called the South Pole. If I turn the magnet around, the South Pole could be here and the North Pole could be here. They are opposites, a little bit like the North Pole and South Pole in the world when you look at them on a globe or a map. Now they do something very special. When you put them together, like this, what do you think they might do? For example, when I put these 2 together, what do? They, what's the word? They attract each other. They pull towards each other. This is for a special reason. So I'm going to write north here and south here. All magnets have this. And south here and north here. The magnets that attract or pull together, I'm going to write pull together or attract, must be opposites. So if it's north and south, they attract. They like to be friends. Imagine who you're friends with. Sometimes you're very different, but you get on really well. A bit like north and south are really different, but they're always together. They attract. What do you think happens? And I can't wait to show you this once I've got the magnets from school. I'm going to do that for my lesson next week. If you've got, I'm going to draw that again. Sorry, guys. Difficult when I'm trying to do this at the same time as filming, but I'm really enjoying it. Okay. What do you think they have to be to push away? They don't like each other. They push away. What was the word for push away? It's the opposite of attract. They push each other away. We call that repel. If opposites attract, what happens when they're the same? So if this is south and this is north, and this is south and this is north. That's right, when they're the same, this should be that way, they push away. When they're different, they pull together. I would like you to draw out 2 magnets now. Not going to have much room here. This one's a small one. It's okay, they don't have to be the same size. Still have poles, all magnets have poles. Can you draw another way that the magnets might push away? Remember, they have to be the same. So when I've got 2 south together, they don't like each other, they push away, they repel. Pause the video, what else could I have here? So I could have north and north because they're the same, which means the other half would have to be south. I always have a north and south. These would also push away or repel because they are the same. This is really important in terms of how magnets are used in real life. Did you know that the world is one giant magnet? So when we did our lesson on rocks, we found out that the Earth inside has lots of rocks and lots of melted rock. So if we cut it in half, we'd see that. But it's also got lots of metal. And down the middle, we have one giant magnet, mainly made of iron. So it acts like a giant magnet. The funny thing is, imagine this is the North Pole. And this is the South Pole at the bottom, the very cold areas, the polar regions. The funny thing is, this is not the north of the magnet just because it's the North Pole. And this is not the south of the magnet just because it's the South Pole. This is actually the the south of the magnet, even though it's the North Pole. And this is actually the north of the magnet, even though it's the South Pole. It's really interesting how the world works, right? Partly, this is why, actually completely, this is why a compass works. Pause the video and think about what a compass is. You might want to look one up, or if you have one at home, have a look at it. So a compass is a device or an instrument which people use to find the way. So if you do lots of walking, or if you are on a boat at sea and you want to find north, you may use a compass. So it's got 4 points. It's got north, south, east, and west. And imagine there's a little needle in the middle which is made of metal, a bit like this clip, and it turns. So when you're walking, so north is not always this way. If you're like this and you're walking, it might turn, and you might hold it and the needle will turn. It might tell you that north's that way. It depends where you are. This works because of the giant magnet in the Earth. This is really, really super tricky, amazing science. If you're understanding this, fantastic. If you think this is actually really quite tricky, don't worry. This is just extra. So I've got my compass. And so never eat shredded wheat, north, south, east, west. So if I imagine, because opposites attract, the needle will point to north when the North Pole of this magnet, so imagine this is a magnet, so this is north, this is south. When that North Pole is attracted to that South Pole, it doesn't have to touch. Do you remember we saw with the earring earlier on? It can attract things from a distance. And you can't see this force. It's invisible. Lots of forces are there but are invisible. So the South Pole of the magnet, which is actually in the north of the world, near the North Pole, I know that's really, really strange to think, attracts, it pulls that needle in your compass, because it's a north-facing needle or a magnet. The north part of the needle is attracted to that South Pole, so it moves to show you if you're heading north. That is a really tricky concept, and I'm sure if you've understood this, you might have understood more than some year 5s or 6s. Put your thumbs up if you think you've understood that. Put your thumbs up if you haven't. Put your thumbs in the middle if you haven't quite understood, but you understand attract and repel. If you're doing this, this is still amazing today. So I would like you to, if you'd like to, as an extra activity, there is a YouTube link I've put in your portfolio on how to make a compass. It's super cool because you can see how the needle moves to face north. If you do this, it's exciting, as when your needle faces north, that means your needle is being pulled by the South Pole, the South magnetic pole here. You can't see it, but that giant magnet in the Earth is pulling your tiny little needle to tell you where north is. Why is that? Because north and south poles are different and they attract. Yeah? And then we know south is going to be to go with the north here. Did you know that this isn't always the case? Because not very often, every hundreds of thousands of years, sometimes this magnet changes. So it's the other way round. The Earth is amazing, which is why I love science. I hope you've enjoyed today's lesson. It was a lot to kind of think about. Next lesson, I will bring those magnets to show you attracting and repelling. Let's say it together, attract and repel. And I'm also going to bring something else to show you as an experiment. We're going to do 3 experiments next time. Super excited. For now, take care and I'll see you soon.